In this question, we are required to find the coordinates of the points of inflection on this curve and justify that these points are points of inflection. Of course, we justify by checking that the concavity changes. Okay, so here it means that okay, so we need to check for that. If concavity changes, then there will be points of inflection. Anyway, step one here will be find the first and the second derivative. So find the first and the second derivative. So the first derivative just means we find, we differentiate the original function, and what we shall end up with is negative 2 sine x plus 1. And then the second derivative will be negative cos x, negative 2 cos x. Okay, so we have that. Step 2, we need to set the second derivative equal to 0 and solve for the potential inflection point. So step 2, set the second derivative equal to 0 and solve for the potential inflection point. So the second derivative here is negative 2 cos x, equate that to 0, and then we need to solve for this, which means that cos x will be equal to 0. Just right here, cos x will be equal to 0. Now, to solve for this, I am going to consider this diagram, unit circle. Okay. Now, in a unit circle, well, that's y-axis and that's x-axis. Now, suppose we have a point here. Suppose we have another point here. Okay. And suppose the coordinate of this point is cos theta sine theta. And this angle is theta, of course, for you to end up with cos theta and sine theta. The coordinates of this point will be, hold on, here the coordinate of this point will be 1, 0. The coordinate of this point, it's a unit circle, so 0, 1. This will be negative 1, 0. And the coordinate of this point will be 0, negative 1. So we can be able to relate a few things here, because these are the values of cos theta, all right, as you can see. Now, if you want to find the values where cos theta is equals to 0, yeah, or cos x is equals to 0, where cos x is equals to 0, we can go back on our diagram and just highlight them, okay? So where cos x is equals to 0, it's here and here. And these are the points where cos x is equals to 0, okay? So that means that cos x is equals to 0 when theta is equal to this angle here is 90 degrees. And this angle here is 270 degrees. So cos theta is equals to 0 when theta is equals to 90 and 270. So which means x here x will be equal to 90 degrees or 270 degrees. But we're working in radians, so that will be x is equals to 90 multiplied by pi over 180, okay? And 270 multiplied by pi over 180, which means x is equal to pi over 2 and 3 pi over 2. Okay, so those are the points where we suspect their inflection points, and we suspect we need to check for change in concavity. So that leads us to step 3. So step 3, use a sine diagram for the second derivative to check for change in concavity. To check for change in concavity. Around the potential points of inflection. Okay, so what we need to do is so this will be our sine diagram for values of x, and we have two values of x. We have pi over 2 and 3 pi over 2. And what we want is to find the signs of the second derivative. So we want to find the signs of the second derivative. So we'll pick test points. Okay, we'll pick test points. So here we'll have we can pick any test points to the left. For example, 0. Here we'll pick another test point. For example, pi. Here you can pick another test point. For example, 2 pi. Now, and we are plugging this into the original, the second derivative. So, for example, if we plug in, if we plug in 0, we know that cos 0 is 1. Okay, if we plug in 0, we know that cos 0 will be 1. So that will be 1. So which means, let me just show you here what I mean. So will be negative 2 cos of 0. And we know that this is 1. Why? Because if you go to the unit circle, you can see that when theta is 0, cos 0 will be equal to 1. Okay? So that will be equal to negative 2. When this is the second derivative. When x is pi, then we'll have negative 2 cos pi, and cos pi is, that's cos 180 is negative 1. Okay, so we plug in negative 1 here. So negative 2 multiplied by negative 1, that will be 2. And then 2 pi will be, because 2 pi, that will be 360, it will be 1. Again, what we need to do is plug in 1. So that will be negative 2, negative 2 cos 2 pi will just be negative 2. So what we have is negative 2, 2, and negative 2. Which means here we have a negative positive, and negative. Okay, negative, positive, and negative. So that means that concavity changes at x is equals to pi over 2 and at x is equals to 3 pi over 2. Hence, this function has 2 points of inflection. Okay? So this means that what we have here basically means that concavity changes at x is equals to pi over 2 and x is equals to 3 pi over 2. Okay? Hence, you can say that this function has 2 points of inflection. Hence, this function has 2 points of inflection. All right, so it has 2 points of inflection. What next? The next step is to try and find the y coordinate. So that leads us to step 4. So step 4, we need to find the y coordinates. So step 4, so which means f pi over 2, that will be equal to, you plug that into the original function, this one here. So what you'll end up with is 2 cos pi over 2 plus pi over 2, which will be equal to, this is 0 cos 90 is 0, so that will just be pi over 2. Okay, pi over 2, which means this coordinate will be pi over 2 pi over 2, and the next point is f of 3 pi over 2, and it's the same thing. That will be 2 cos 3 pi over 2 plus 3 pi over 2, which will be equal to 3 pi over 2, because the cos of 270 is 0. So what we end up with is the coordinate here will be 3 pi over 2, 3 pi over 2. And these are the points of inflection of that function.